Hey everyone, thanks for joining us for the next session of our RAG Deep Dive series, RAGChat, Storing Chat History. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. Our session is being recorded. It'll be available to view on demand within 24 to 48 hours right here on our Microsoft Reactor YouTube channel. With that, I'd love to turn it over to our presenter for today, Pamela. Thank you so much for joining us.
Hello, everyone. Welcome to this RAG deep dive session about chat history. You can grab the slides from this URL here that we're going to put in the chat, aka.ms/rag deep dive/chat history/slides, and you can use those slides for whatever you would like. So for those of you who are new to our RAG deep dive series, this is an 11-part series. We are halfway through it now. If you missed any of the earlier ones, you can grab the recordings on YouTube and catch up. And you can still register to get notified about the upcoming ones that we're having through mid-February. So we'll put the link in the chat to register for all the upcoming sessions so that you get notified. And if you ever miss one, just watch the recording on YouTube, and you can also grab the slides that you see on YouTube. So in this series, we are diving deep into our most popular RAG solution for Azure. This is a solution that is based off of Azure OpenAI and Azure AI Search, and then is deployed on either Azure Container Apps or Azure App Service. It starts with some basic features, but then it has tons of optional features as well. And we're exploring a lot of those optional features in this series. So you can grab the code for it from this repo here, aka.ms/RAGChat. That'll open our GitHub repo. And you can see I very recently made a change 42 minutes ago, just in time. And you can see all the docs here and get information about how to get started with it. There is also a live demo that you can check out that it only has a few of the features enabled. But to get a feel for the application, if you haven't used it yet, you can check out this live demo. So we're going to talk about how we handle a few things for this app. First, about how we just include message history within a RAG flow and how we do token truncation for the message history. Then we're going to talk about how we store conversation history. And you can actually see one version of that in this demo URL that I shared with you. And so you can see these are questions I was actually asking just earlier today. So we're going to talk about that. And we're also going to talk specifically both about how we can store conversation in the browser using IndexedDB and how we can store it server-side persistently using Cosmos DB. So first, let's talk about how we include message history within the RAG flow, how we send it to the model, and how we handle truncation. So what I mean by message history is, let me go ahead and ask a new question. So we're asking what's included in a plan, yada, yada. Okay, and then I say, does it include vision? Okay, so here I'm asking a follow-up question. So this is really common in conversation, is that you ask a follow-up question, and your follow-up question references something in the answers or the questions from before, right? And you can see that the answer here was perfect. It knew what I was talking about and said, yes, it does include coverage for vision exams. So this is what I mean about message history, is the ability to have a multi-turn conversation and for the model to be able to incorporate everything from previously in the conversation. And that's what we want when we're having an actual conversation, a multi-message chat with a model. So let's look at the RAG chat flow for a single message to understand how that works. And then we'll see what it looks like when we add more messages. So let's say we have this question, right? Does the Northwind Health Plan Plus Plan cover eye exams? So let me actually type that in here. Does the Northwind Health Plus Plan cover eye exams? Okay, and it says, yes, it does. Okay, so what happened here is that we got the user question. We first used an LLM in order to rewrite this query into a better query for our search index. So we got back, a better query like Northwind Health Plus plan coverage details. Actually, I should change that query. Let's see what we actually got back here. Right. Okay, here we go. It says Northwind Health Plus plan eye exams coverage. So that's what the LLM thought was a more appropriate query than this question. So it's, it gets rid of some fluff and maybe adds in, a different kind of wording. Okay. So that's not super impressive. But then we use that query in order to search AI search and get back resulting documents, right? So that's actually what you can see here. I'm in the thought process tab. So if any of you are in the app, you just click the light bulb and then you can see the thought process. So we get back a bunch of search results that match that query. And that's from our AI search index. And so we get back those results. And so then we send the original question with those results to the LLM and we get back an answer. So that's our flow with a single message. So just keep that in mind. Now we add in an additional question. So we say, oh, hearing too. And it says, okay, it also covers hearing care, blah, 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 lots of stuff. Okay. So now there are multiple messages, and this one references previous questions and answers, right? So we want everything in our RAG flow to incorporate the history. So we actually send the entire history to, or everything we can fit, we send it to the LLM when it's doing that query rewriting, because then we get this really nice query, Northwind Health Plus plan coverage for eye exams and hearing, right? Let's see if that's what we got this time around. Oh, this time. That's great. So this time it actually did not do a very good job. Oh, LLMs, it just changed it to hearing. Usually it does a better job incorporating. So when I ran this before, I got like this really good result. This time it's being a bit lazy and just said hearing. That turned out to be an okay query in this case. Usually it's best if it can incorporate a little more information. So we use that suggested query in order to do retrieval with AI search, get back the results that talk about hearing, and then we send the full, like all of these messages to the LLM plus those results to get the answer. Because we definitely need the LLM to have some context, because it needs to understand, what is this question hearing to? If we only sent the question hearing to an LLM, it would be just guessing what our original question was, right? It needs to know that the actual question is, does the Northwind Health Plus plan cover hearing to? So by sending it the previous questions, it's able to fill in that missing context. So it's really important, especially with multi-turn conversations that have these follow-up questions. It's very important that we're sending the past messages so that the LLM can fill in that missing context and can answer it correctly. And so then we get back a correct answer. Okay, so the thing is that there's a problem, is that imagine you have a really long conversation. Maybe you're just talking a really, really long time with an LLM. You're having fun exploring some topic. So maybe you've got 100 message, 200 message, whatever. The issue is that LLMs have limits to how much context window you can send. It's called the context window limit or context length or something like that. And there's a limit for each of the models. You can actually see it in the documentation for models. You should always be able to check and see, like, okay, what's the context limit. Now it has gotten a lot bigger recently. So that's 01. Let's look at this one is actually still GPT-3.5 Turbo. I need to update it. But if we look at a GPT-3.5, it has a context window limit of 16K. So that's how many tokens we can send to it total, is 16,000. Now, if I upgrade to like GPT-4 or GPT-4o mini, then we actually have much larger context windows. So this becomes less of an issue. So 128,000 in English, that would be about 128,000 words, including the search results. which would be like a really, really long conversation. So this is less of an issue as we're using the new models. But if you, especially if you're using one of the models that's like between 4 to 16K, it's definitely an issue that your conversation could go over that context window. So what we do is we truncate the message history to only fit what can go inside your model's context window length. So what I do is I start from the bottom, always send the most recent message because that's what user want an answer to. Then I send however many of the previous messages fit inside that context window for that model. And then if something doesn't fit, they get discarded, right? So the oldest messages that don't fit get discarded. So this is a strategy by which we can send as much as possible while also never risking getting an error of, uh-oh, you've gone over the token limit, because that's an error that a user wouldn't be able to recover from. They'd have to start a whole new chat, right? So this is why we truncate the message history. And I talk about this because I think a lot of people don't realize that this is something that you really want to consider having inside a chatbot that uses models. There are other approaches like summarizing the past message history that would involve bringing in a new model. So we use the truncation approach here. So it's just something to keep in mind, like models have limits to how much you can send. Is there a possibility that a user's conversation could be so large that it exceeds that limit? If so, you need to handle that. So Sadiq says, if the search result is part of that context window limit, then what's the number specified separately for the output? So when I do the truncation, I also have, I know the search results in it. So I guess I'm not showing it in this visualization, but like Hearing 2 would have all the search results there. So I keep that in mind when I'm doing the truncation. So I have all the possible things we're going to send, right? Because if you look at the we go back to this thought process, and we can see in the thought process, there's like the system prompt, right? So I also need to know how long the system prompt is, because I'm always going to keep the system prompt for sure, right? So I keep the system prompt, definitely. Then I keep the most recent message, and that most recent message has the sources in it. It has those retrieved chunks. So we're definitely going to keep that. And that shouldn't go over the context window limit, right? Unless you change your retrieval to retrieve like a lot of results. Like if you're retrieving like 30 results and you're using a model that has a lower limit, like 8,000. And also if your conversation or your results are in a non-English language that requires higher token count ratio, like for Chinese, Japanese, Korean, those might take like 3 tokens per word, which means you need more tokens to represent the same number of words. All of that could affect, how large that thing should be. But generally, you can always fit in the most recent message, right? And then we just go through and like, okay, we can fit this one, we can fit this one, right? We just go through the past messages until we can no longer fit them. All right. So that was my explanation of message history and truncation. So now we can move on to how we can store conversation history in the browser. And this is probably what you're here for. So here's an example here of having the RAGChat app with the browser history option. And you can test that in the demo URL that we already shared, and we can share it again. And there is docs for enabling that in this repo, so that you can just follow that doc there in order to enable it on your version of the repo if you got a deployment of it. So as you can see, we've got that chat history, and it's listing. Now here I only have ones from today, but if we had ones from like a week ago or whatever, it'd be like a week ago, a month ago, etc. And then we can click on any of them. That's really impressive. Oh, maybe it was because of the, okay, cool. I just managed to come up with an error. I'll have to see if I can replicate that later. Maybe it was the thought process being open, but you can see here, I'm clicking around and opening up the previous conversation. So that way a user can see some conversation they had earlier and reference it. And this was a really big feature request for a long time. So we're really happy that we have this in the solution now, because this is something that customers, users have come to expect, because they have it, in ChatGPT and other apps like that. And so they want to have their history. Now, I want to thank a contributor, Vegeta H, for this feature. And, in our repo, it is an open source repo, and we often get contributions from the community, which is, all of you that are watching this, using this repo. And this was really great that Vegeta H went through the effort to create this feature, both the browser version and the Cosmos version, and they wrote it in a really nice, extendable, flexible way and iterated on it. And so just big shout out for that contribution. It's really great to have this in the repo now. So for this change, it's a big change because we need both front end, back end, and we also need infrastructure. So on the front end, our front end is written using TypeScript and React. So all of these, this JavaScript I'm showing here, these classes, these are all JavaScript or TypeScript classes. And it's written, I was saying, like, this chat history feature is designed to be extendable and flexible. So, we've got like the actual UI, which is the history panel. And that one can use a history manager. And, that could either be a Cosmos DB provider or an IndexedDB provider. And they have the same interface, but they're implemented very differently because one of them is stored in the browser. The other one is stored in Cosmos DB and requires a server call, right? And in theory, we could add other providers in the future. If there was a desire like for a different database, like maybe you could do a different local database like local storage, or you could do a different server-side database like Azure SQL, PostgreSQL, etc. So first we're going to look at this client-side mechanism, and it's using this IndexedDB, which is something that you can use on all browsers. If we go and look at caniuse.com, which is a great website to find out if you can use something across browsers, right? And IndexedDB, you can see the support for it is in 98% of modern global browsers, which is basically all of them. So maybe usually it's mobile and iOS that's maybe the most behind, but it's been around for a long time, and so we can safely use it. And we can actually just go ahead and open up the dev tool. So what I just did was, if you are in like Edge or Chrome, you can click inspect on the website, and then you go to the application tab, and then you go to IndexedDB. And when you expand it, you'll see a database. So with the IndexedDB, you do actually set up a database. It's basically like a document database, but local. So you say, okay, this is my chat database. And then, this is a container inside of it. And what you see is a bunch of keys and values. So the key is a string and the value is, JSON. So here we can see, what does a product manager do? That's our oldest item in the database. And it has the title, and that's what we see displayed here. And that's just based off the first question. And then it has sets of question answer pairs, right? So we have, what does a product manager do? And then there is the response here that has everything needed to reconstruct the response. So it's got, it's got all the thought process in it. So it's not just the string, it's the full information needed to reconstruct this user interface, right? And we could look at one that had a follow-up. So if we look at one that has a follow-up, then we've got more question answer pairs in that list here, right? So what's included? Does it include vision, right? So you should actually be able to see that yourself on that live demo if you want to explore what the IndexedDB looks like. And that's implemented in this indexeddb.ts. So you can see that it's basically using TypeScript in order to query our local database. We got comments in Japanese because Fujita H, I believe this is Japanese. I'll have to translate that comment, and maybe remove it if we don't need it anymore. But that's great. So yeah, so you can explore that code if you want to see what the IndexedDB code looks like. However, the big issue with IndexedDB is that it is a client-side mechanism. It is a browser-side mechanism. So that means if I go ahead and go to a new browser or even a new browser like incognito or whatever, then I'm not going to have my chat history anymore, right? So I could go to, I could go to Chrome. Currently, I'm in Edge. And here's Chrome opening up. Bouncy, bouncy, bouncy. Okay. Let's see if I have any chat history on here. So no chat history. So as you can see, I've got chat history in one browser and no chat history in the other browser. And that's what the experience is when you're storing something in a browser, is that it doesn't go across the browsers, right? And that might be fine. Like maybe for your features, like maybe for your users that they're okay with that. That's maybe they don't expect persistence. Like maybe they're only using it lightly. Maybe you don't want to invest in spending money on storing their chat history. So for those of you who are okay with that, then you can use that feature. It's free, doesn't cost any money for anyone. And, that's what's great about it. But if your users want that conversation history to be persistent, then we need to store it in an actual database that's in a cloud somewhere that we can then keep up alive all the time and not lose that data. So we started off with Cosmos DB. It's a really good fit because it's a document store, just like IndexedDB. It's very fast, very performant, and it's really it's recommended for these kind of use cases. Like user-specific data is a great thing to be storing in Cosmos DB. So this is what it looks like with the Cosmos DB history. The big difference here is that in order to use the Cosmos DB history, you do need to be logged in, which means you need to have our user login feature enabled as well. We talked about the user login last week. So once again, you can watch that stream if you missed it, or you can just read more about it in our docs. But you do need to have that user login feature enabled because we tie all of the chat history to your Microsoft Entra user ID. So it builds on top of that user auth flow. That's the main difference, is that now we've got that logout. The UI looks the same because we're reusing that same interface. The difference is, just where it's getting that data and how it's going to store it. So there's the docs where you can learn how to enable it for your repo if you're deploying this repo, and get it going. So how do we store it with Cosmos DB? We can actually look in the Cosmos DB Data Explorer and see what it looks like. It'll look very similar to what we saw in IndexedDB. So here I'm in the portal. So let me just show you where I am. Like I'm in the portal for my Azure Cosmos DB account, and I'm using the Data Explorer. You can also use this separately at cosmos.azure.com. And it's basically the same thing. You just go and connect to your Cosmos DB account, and then you can open it all up. And so here we can explore what is in our container. And it looks kind of like IndexedDB, but we actually went for a different schema with our Cosmos DB setup than our IndexedDB setup. So let me explain the schema that we went with, and we can go back and look at it again. So what we have is that in Cosmos DB, we have a database, and in that database, there is a container. And that container uses what's called a partition key. And we're actually using hierarchical partition keys. And partition keys are great because when you use partition keys, when you limit your queries to those partition keys, then they can be very fast because they only have to look inside that partition. So if you can, it's really, really good if you can use partition keys. And that is also why Cosmos DB works really well for stuff that is tied to a user, because then you can naturally use the user's Entra user ID as that partition key, assuming you're always going to filter based on a particular user. So that's what we're doing here, is that we're using Entra user ID as a partition key. And then we have an additional partition key. And this is what's known as a hierarchical partition key. So if you do two partition keys, then you can query by like just the first one or the first one plus the second one. So that works like for this case where we have Entra OID, which is the top level thing we want to filter on. And then sometimes we also want to filter by just a particular session ID. And a session is basically a conversation, right? So that's how we're doing it. And that's the best practice. We also have a version of this in .NET. If you're a .NET developer and interested in that, I can get the link for you. So within that partition, we have multiple documents. The first one represents the session's metadata. So that has the title of the session and the timestamp that it was started. And that's what we see like displayed in our, sidebar. That's the session metadata, right? It knows the time and it knows the title. And we give that a type of session. So we say this is type session. Here's its title. Here's timestamp. Then we have all the message pairs for that session. So that one has a type of message pair. And then there's the question, like what does a PM do? And then the response, which has the full JSON response, with all the thought process in it. And so we would have more message pairs if there was a follow-up. Every follow-up is going to be another message pair, in this partition. And then if we had another user with their own sessions, that would be another partition under this hierarchical partition. And they would have the same thing, like the session and then the message pair. So now we can go back to that Cosmos Data Explorer and actually see, right? So we say, okay, what happens in a performance review? And that's the type session. Let me make that a little bigger. Actually, I think it's clear when we go over here. It's bigger. Yeah, here we go. All right. And then we look at the next one. And this is the message pair that's part of it. So we have the question and we have the full response. And you can see in the response, we've got the context, we've got the thoughts, and then we have the actual answer here. And that gives us everything we need to be able to reconstruct that conversation in the interface, right? So going back here, that's this one we were just looking at, what happens in a performance review, right? With these items, we're able to construct this conversation again. So Ahmed asks, if filtering using the partition key is fast, doesn't relying on the type, isn't that relying on the type property can impact badly performance? Yeah, that's a good question. We're going to continue, even though we have a type, our type is all within the partition. So we're going to first filter by the partition, and the partition is actually like really small, right? Because look at these, this partition, it's only got 2 items in it, right? So for this, because remember the partition is like the combination of the Entra ID and the session ID. And so when we're querying for just a partition, like that should be very fast. Maybe you're asking when we do the query where we get all the sessions, we're still at least limiting to the Entra OID partition. So we've already filtered down to the user. So that means that it could have thousands of documents, but only thousands of documents. And so as far as I understand it, like with thousands of documents, like it's going to be a very fast query because, we've already filtered it down to only the documents that are in that Entra user ID's partition. And then Ahmed also asked, would it be better to have 2 containers, one for session metadata and another for messages? Yeah, we considered that, but this is what was recommended by actually the Cosmos DB team, because this is also what they do. Let me go ahead and get that sample up so we can share it. This gives us more flexibility so that if we do, because sometimes what you'll see is that sometimes we do need to filter for both types at once. And when we do need to filter by both types at once, it's better to have them be in the same container, because we're gonna filter by the Entra ID, the session ID partition, and they're all gonna be right there. So that's why we do it, is that it gives us the fast queries when we do want to get multiple types at once. And then there's a question about, will the ID be using the new GUID or is it using the old GUID? Well, for our ID, we're actually passing down the ID from, I think we're doing it actually from the server. Sorry, from the front end. So we're sending the ID from the front end. But that does make me wonder if maybe, I'll look into that, whether we should be doing that a different way. whether we should be doing this on the server. I'll have to check to see what we're doing in the .NET one. Yeah, that's a really good question. I'm gonna look into it. Right now, what we're doing is we are actually constructing it. Let me see if I can find where what did we use for it? Not there. It's hard to search for ID because it's a really common. It's a really, really common, like, name in your thing. So I can't remember where we set it, but we are. You can see that we're sending it. We're sending it from the front end. So that means our front end is setting it. So I have to remember how the front end is setting that ID. Maybe I could do it. Okay, I'll dig into that because I really like that question, and I want to see exactly how we're setting that ID. Okay. So continuing with the Cosmos DB, this is how we configured this container in our bicep. The bicep is the infrastructure as code. That's how we provision everything in this project. And it's a nice declarative way of describing our infrastructure. So what you can see is that we have the chat history name, then the paths, and that's your partition paths. So in this case, we have 2 paths because we're doing 2 partition keys, a hierarchical partition key. And so we just give the names of those fields inside the document. So we say, okay, there's Entra OID and there's session ID. So you can learn more about that in the Cosmos DB partitioning overview docs. And there's some docs specifically about hierarchical partitioning because they can be a bit different. And because it's a hierarchical partition, we also have to say kind multi-hash. So that's because it's using 2 partitions, and we need to use multi-hash. Okay. And then we have the indexing policy, which describes what gets indexed. Like we need to index the fields that we're going to be filtering by. That's the general way you should think of it. And so what we say is like, okay, make sure you index Entra OID, make sure you index session ID, make sure you index timestamp because we're going to order by that. And then also index type because we're going to filter by type. So these are the ones that we're including in our indexing policy. And you can also read more about the indexing policy here. And then it's saying don't index anything else. You can also do the reverse. Like you can have it like just always index any field unless you decide to exclude it. And we are actually doing that previously, but it might be slightly better to do this because then you don't get any surprises with like spending a lot of energy on building indexes for fields that you're never going to filter on. I see there's a question from Sadiq. Is Cosmos DB an equivalent of a managed MongoDB service? That's a really good question. So Cosmos DB actually comes in 2 flavors. There's Cosmos DB NoSQL, and that's what we're using here. And then there's Cosmos DB for MongoDB, where they've actually made an API layer equivalent to MongoDB so that it acts just like MongoDB. So if you're somebody that has a MongoDB code base already, you could move to Cosmos DB for MongoDB and be able to use hopefully the same code. And just generally, they're both document databases. So you can think of it as a managed document database service, which exposes either this NoSQL flavor, which is just a custom SQL query language, or which exposes a MongoDB interface, which you could use instead. So I'm using the NoSQL because I don't actually know Mongo myself, so I don't want to have to like learn the Mongo flavor as well. But if you are already a Mongo developer, then you would definitely want to consider doing Cosmos DB for MongoDB. Okay. Ahmed figured it out. It was okay. All right. Thank you, Ahmed. So it was actually the UUID from Python. Okay, because we're getting it from the session state. I forgot. All right, we got it from the session. Yeah, you're right. I should have just clicked through. So we have this function. So the front and back end are like passing this back and forth. Okay. So for both of them right now are using the same strategy of UUID4 from the Python built-in package. Great. Thank you, Ahmed. All right, so let's look at the code for this, right? We were just talking about the NoSQL. So the code is using the Azure Cosmos Python package with the, this is the NoSQL flavor. So this is what your code might look like if you're, using that package. So the first thing we do is like when we insert a new, a new chat history in the database, right? So if I ask a new question, like what's the whistleblower policy? Okay. And I'll open up my network tab too. Let's see, did I do it in time? Okay, network tab. Okay, so what you can see is that there's a post to chat history. All right, so you can see it goes to the /chat history. It does a post and it got back a status code of 201 created. So that's the first time at which it stores this particular session in the database, right? And if we go back to the database, if we can do a little refresh, do we have a refresh here? I don't, well, we certainly have a reload the page option. So we reload the page. It might also be a refresh thing, but we go here, we look at our items, and now we can actually see this is the one that just got added. So this was a result of that network request, is that it added the session metadata, and then it added the message pairs. So how that works is it does a post to chat history, and that one uses batch operations in order to do an upsert of the session plus all of the message pairs that come in. So we're doing a batch operation because we want this to be transactional. Like we want all of them to get inserted or none of them. So that's what we get out of a batch operation, is the ability to have it be a transaction where either everything happens or nothing happens. And then we're doing an upsert because we want to either insert if it's never seen this before, or we want it to update if it has seen it before. So we're always using upsert instead of insert because we always want this kind of behavior where it either does the insert or update. So if you haven't seen upsert before, that's what it means. It's either inserting or updating if something already exists. And now the crucial thing here, you can see the partition key is a list of the Entra OID and the session ID. So that's how we're limiting this operation to just that partition. So it makes it limited to a very specific partition, which is really helpful. Okay, so now it's in there, and we can also, you can look at the full code for this in cosmosdb.py. So you can see this is a post to that endpoint. We grab all the data from the JSON, construct that session item, construct the message pair items, and then do that batch operation. Now, the next thing is getting a list of all the sessions. So this is what we use when we're opening up this tab here, right? So you can see it makes a request to sessions with count 20. So this is actually a paginated display. Now, the interesting thing is it doesn't look paginated because, well, one, I have less than 20 right now. But two, even if I had more than 20, it's actually using an infinite loading interface. Like it detects when we get to the bottom of the scroll area, and at that point it goes and does a request for more. And so this is a nice interface, right? Because most of the time users are going to be looking at their fairly recent conversations, but if they want to look at older conversations, they can keep scrolling and it'll pull in the older stuff by looking at the next page. So for that, we need to do pagination. So how do we do that? Let's go ahead and just look at the code for that, right? So what we do is we look at the count, and we also look to see if we've been given a continuation token. So by default, we assume we're not given a continuation token, but if we are, we'll use it. And then we do our construct our query, and in our query, we're looking for just the session types because we only need that session metadata, and we're ordering by the timestamp. And once again, this time the partition key is just the Entra OID, right? Because we're looking at sessions across that whole partition, so we can't limit it to any particular session. So we're doing just the Entra OID. So that's what is neat about hierarchical partition keys, is that you can do just the top level, or you can add on, the child levels as well. And then we have our max item count, which is 20 because that's what we passed in that network request that we saw. So this is going to grab 20 sessions. Then we call this by page function and we pass in the continuation token. So the interesting thing here is that you might look at this and think that this has done a network request, but this actually has not done a network request yet. This is basically prepared a query, but it's not going to do a network request until we get to this by page function. because it needs to know whether there's a continuation token so that it knows like where to start looking in that query. And you can think of the continuation token like a bookmark, right? Where it's like, okay, I'm going to start like at this particular offset in the query. And if that defaults to none, it just, it'll just grab the first page. And so that's what we're doing here. It's just going to grab the first page because we didn't pass in that continuation token. And so then we need to get just the first page. And this is crazy looking code. But basically this says get the next page. And I know this looks really, really crazy. This is because we're supporting Python 3.9. Once we move to Python 3.10, we will have a much nicer thing we can do, which we can do just do a next. Unfortunately, to support Python 3.9, we can't do that yet. But if you've ever used an iterator, you might know the next function. So there's now an a next for asynchronous iterators because we're doing the asynchronous. We're doing this all asynchronously now for performance reasons. So that does make all of our code more complicated. So if you're looking at this and thinking like, what? Yeah, don't worry. This is crazy looking code, and hopefully we can simplify it as we move to Python 3.10 next year. By default, we deploy to like Python 3.11, 3.12, but some people are developing in Python 3.9 locally, so that's why we support Python 3.9. So basically, this grabs the first page. So this is what's called an iterator. It's an async iterator. We grab the first page out of this iterator. So this is really what's going to do that network call. It's going to be here. And if there's a continuation token, and there's only going to be a continuation token if there's actually any additional data. So in this case, there wouldn't be. But if there is one, we'll grab it. And then we send down both the sessions that we get from that page and any continuation token that we received. So let's look at that browser tab because oh yeah, it's already open. Let me just pull it up here. Okay. Okay, so there's that get, count 20. And then what you can see here is that the continuation token is null because there were no additional pages. If I had more than 20 conversations, 20 sessions, then I would get a continuation token here. And then the interface could use that to do the next call. So that is how we do pagination with Cosmos DB, especially over an API, right? All right, so then moving on. So we've gotten the sessions. Now we want to deal with particular sessions. So we can do a get on a particular session, and that's what happens when we, click on one of these sessions, right? So we'll go say, what butterfly can I find? Okay. And then if we look at the network request here, we'll see that it makes, it's getting a little big. Let me make it smaller. It makes a request to /chat history /sessions /really long session ID. And then, sends back this response, and we can use that to make the session render in the UI. So what that looks like in the Cosmos DB code is that we select from the container where the type is message pair, because that's all we need in this case. And our partition key is going to be the Entra OID and the session ID, because we can filter down to just that session ID for this query, because that's all we care about. You can just go ahead and check that code here. Right here's the code. We get the session ID. We do that query. We go through each of the page. So here's an example where we're actually exhausting all of the pages, because in this case, I wanted to send down the whole conversation, because I assume that if they're loading the conversation, they probably want to see everything, right? So I send down the entire conversation. And so that means this is an async for loop. So that's what you have to use if you're dealing with an async iterator. You have to use an async for loop. So we say async for page and res.byPage. And then also async for item and page. So there's a lot of these async iterators used in the async SDKs. That's why things can get a little confusing, because many of us are new to async. But luckily we've already written the code, so you can see how it works, right? So if we want to exhaustively get all of the items matching a query, then we're going to use this by page and make sure we get every single page. So in this case, we're going to pass down everything and not pass down a continuation token. All right, so finally, if we wanted to delete, right? So if I go here, I can click on this, delete, and that sends a delete method to the same URL that we just used to get it. And then we get back a 204 saying that's deleted and there's nothing to report. So let's look at the code for that one. So here we're looking for everything that has the session ID. So whether it's a session type or it's a message pair type, we want it all. So this is a situation where it really helps that they're in the same container because we want all of them. So we can just look for basically everything that's in this partition. We're gonna grab it all. And then we exhaustively go through all of the pages that match and we get the IDs for each of them. And then we do a batch operation, sending all of those IDs and deleting them all in a single transaction because we either want it all to delete, or if there's an error, we want to know about it and not do a partial delete because that could get really awkward. And there we go. That is the Cosmos DB routes. And yeah, now we can do some questions. I even have like a pre-populated question here, but I know there was a couple other things that we missed. So Wayne, right back then, said, how do you evaluate if the query rewriting actually improved the query input? So that's a really good question. And it's actually something, I mean, generally we're going to talk about evaluations in like 2 weeks. I think I'll talk about evaluations. And when I evaluate, I do usually evaluate the entire RAG flow from start to end. So if something like if we made a change to the query writing and if it did significantly improve results in the end answer, then I would be able to see it in those results. You could also evaluate just that query writing step itself, but you'd have to have some criteria as to whether like, was that a good result or, what does a good result look like, right? So I think it's easiest just to evaluate the entire flow so that, if you do decide to tweak that query writing stage, you can evaluate that whole flow. And then especially with query writing, if you're doing evaluations, you'd want to evaluate on both single turn conversations, but also multi-turn conversations, because multi-turn is where that query writing can really have a big impact. And that's something I need to work more on. Currently, I'm mostly evaluating single turn conversations, but especially for query writing, we really want to be evaluating multi-turn. And there is actually a PR that's been open for a while that does attempt to improve the query writing step. It's like way over here. And I haven't merged it yet because I want to have an evaluation flow set up that can really, really test to see if this improves. So I need to add multi-turn evaluation. So yeah, in conclusion, I would evaluate the whole RAG flow and make sure to include both single turn conversations and multi-turn conversations in those evaluations. And then I think you should have a good idea as to whether things have improved. Cool. Okay, Sadiq says they're going to use the DeepSeek coder to improve the code and we'll send a PR. Great. I look forward to seeing it. So, now on Copilot, you can ask Copilot to do a review. I don't know if they'll do it now that it's already closed. I've tried it and haven't gotten, I didn't try it on this one. I wonder if can I will it work? Because this is a closed PR now, but it does say awaiting requested review. It'd be cool to see what it suggests. I think it's always, my colleague Anthony has been playing around with like O1 and R1 and stuff, and especially for code improvement situations. And I think there is some potentially really promising stuff there. We all using like GitHub Copilot and stuff like that. It can be really good. Like, so trying queries like, how would you improve the performance of it? Did I miss any edge cases? Those are all really good queries to ask a LLM and also ask multiple LLMs, right? So like, with your Copilot chat, you can switch out, different models here, right? So here I can do 4.0 or 0.1. I can't do Claude internally, but many of you will have Claude as an option here too. So a question like that about how would you improve this code can be a good one. Let's just try it on here. If it thinks like, I'll just ask Copilot and let's see, I'll just do inline chat How would you improve this code? Oh, and we can change the model in inline chat now. That's cool. Okay. I didn't know we could change the model. Let's see. Oh, okay. Interesting. So it used an async for with a break. I think its indentation is wrong, but basically it's saying do an async for and then break. And maybe that's nicer because then we don't have to do the .a next. So I guess that's nicer. It feels weird to me to do a for loop and then immediately break, but also using the a next function also feels weird. All right, let's try it with, okay, let's discard it and then try the same thing with the O1 model, right? Okay. So Alex asks, is Copilot Review also available in Azure DevOps? I have to admit, I haven't used Azure DevOps for code since I only work on GitHub repos, so I don't know. I would guess not because I haven't heard of it. But it might be. You could look it up. See if you can find anything we search. Okay, so O1 suggested using a next, but I can't use a next because of the Python 3.9 support. So it's right that a next would be good. So let's see if I accepted this and then also fix the indentation. I get an immediate squiggles here because I have a linter that warns me if I'm using something that's not available in our minimum Python version. And so that's good. That's why whenever you're using these tools like Copilot, you should always also have linters in your environment that will immediately warn you if that tool thinks you should do something that actually violate some linting rules, right? Okay, so custom GPT solution says, how would we control the user's questions that are not relevant to the document? Yeah, that's a good question. So let's go ahead and try that. What started the Big Bang? That's actually a question that has plagued me for a long time. All right, so what started the Big Bang? Like, what was before it? What was the universe? I don't know. It's so weird. Okay. Okay, so in this case, this is good. This is the response we want in a RAG application. It says, I'm sorry, but the sources provided do not contain any information about the origin of the Big Bang. That's what we want because we want it to stay on topic, at least for my implementation I do. If you were okay with it answering it, you could let it know. But the reason it's doing that, because if you look at our system prompt, we are very clear that you only answer the facts in the sources. If there is not enough information, say you don't know. Don't generate answers that don't use the sources below. We're really, really explicit about that because we want it to have that behavior. If you're okay with it using its own information, then you could change this prompt and then it would get what was in the weights. But what a lot of people want is for it to stick to the topic. And I have a whole blog post about evaluating what I call don't know-ness, which is the ability of your RAGChat application to admit when it doesn't know. And most of the times it does do a good job as long as you have, you're saying in the prompt. But sometimes it can be really tempted. Like it really likes saying, in my experience, it really likes saying who painted the Mona Lisa, right? Like facts that are just so like everybody, well, I don't know if everybody knows it, but I recently read the biography about it. Oh, that one got an error. Oh, it's because I'm not logged in. Sorry. What window are we in these days? Let's go. Who painted the Mona Lisa? That might have been my local. I've got so many tabs open now. Okay. So that's because that's funny. That's because I happen to have in my personal file uploads here. That's something we talked about in a previous one. I do happen to have the Wikipedia about Paris, which probably does have the Da Vinci in it. All right, let's find this one. Okay. This is the one with the Big Bang. All right, let's try who painted the Mona Lisa. Yeah, it's the Mona Lisa was painted by Leonardo da Vinci, and it cites a plant sign about sunflowers. So this is one of the trickiest questions that I've found is that LLMs really, really like to claim that they know the answer. Now, there are approaches to this because what we can do is look at these results and see that they rank really lowly. So this is what's called the semantic re-ranker score. 1.6 is a very low re-ranker score. That means it's basically a garbage result. So what we should do, and I think we should probably default the repo to this, but we can set a minimum re-ranker score and say like 2. We can even do like 1.9 in this case. And so that way we will not return documents if they don't have at least 1.9 re-ranker score, right? We even do 2. Like 2 is actually still pretty low. It goes from like 0 to 4. So we'll say 2. And then let me clear the chat. Make sure we still have that setting. Okay. And then say who painted the Mona Lisa. And see if it, okay. So this is interesting. This time it still said it was painted by Leonardo da Vinci, but it could not figure out a source because there were no search results matching it. So in some ways we improved things because we forced it to hallucinate a source. So you could actually like say like, listen, if you could do like we could do some logic that says like, listen, if the source like doesn't actually match a source, like it's probably not a good answer and we should just discard it, right? There's really interesting things we can do here. But importantly, we've removed the search results that were distracting it into thinking it could justify its answer. So that's one thing I would recommend is that I think most people should have a minimum re-ranker score of 2. You could experiment with a little bit below, a little bit above. But that's a pretty good score level there. And maybe we'll default to that in the future just so we don't give it any distracting results. Because the issue here is we're using hybrid search. Hybrid search is both vector search and text search. And vector search will always find a result. There's always some vector that's close to the vector of your query. So when we're using any sort of search that involves vectors, we really want to have a score threshold. And the semantic ranker scores are really good ones for setting thresholds because they have pretty clear meaning, like 0 to 4. 4 is great, 0 is absolute garbage, and 2 is still pretty weak. And then we still have the issue that some questions it really wants to answer. But you could say like, well, if none of the sources match, maybe we just say, sorry, there's no answer there. So interesting there, but that's probably the question I found that is the most tempting for an LLM. Now, the other thing is that I'm using GPT-3.5 Turbo. GPT-3.5 Turbo is an old model. Like we need to upgrade it to GPT-4o, GPT-4o Mini, and a lot of people just use this repo with GPT-4o and GPT-4o Mini. And you'll get better results with this question. When I evaluated questions like that, what I found basically was that the best way to improve the ability of your app to say that it doesn't know is to improve the model. I tried lots and lots of prompt engineering, but didn't get anything better than our current prompt. But as soon as I changed the model to a newer model, it was much better at saying when it didn't know. So, so that's what I do. I'd set a score threshold. I would use a newer model and run evaluations and, see how it does. Great question. We could talk about that all day. Okay. We've got 3 minutes left though. All right. So Paolo asks, how do you catch and process messages related to safety and content filters so that UI does not show the error message from the LLM? So for that, we do have code for that. It's the error.py. Okay, so what we do is, let me find the code that triggers this. Okay. All right. So when we run, when we run the RAG flow, we do a try except, and if there's an exception, we call this error response function. Now, in this error response function, we check to look at the type of the error. If it is an API error, which is from the OpenAI SDK, and if the code is content filter, then we can give a particular error. So you could customize what your error is there. So I actually for the error dict, so I customize the response based off the type of error. So if it's content filter, I say your message contains content that was flagged. You could change that to something else if you don't want to reveal that it was flagged. If you just want to say, sorry, I can't answer it, like you can change that to whatever you want. Some people wanted to like refer people to their HR documents. Right? So it's designed so that you can sub out your own message there to whatever you need. And then I also have a custom message for content exceeded. Generally that doesn't happen because of the truncation, but if people do like try and retrieve like hundreds of search results because they're messing with the settings, then you could get that. So I have that one there. So yeah, basically you catch the errors, you check to see if the error is the content filter error, and then you can decide what you want to display to the user. Sadiq asked, so temperature has no effect? I've tried different temperatures. 0.3 is generally really good for RAG. Temperature can have some effect. It hasn't had a, I mean, if you go into extreme temperature, like it does have an effect. I don't think it had an effect on don't knowness, but like I'd have to run the queries. Yeah, you're right. Okay, we could try temperature 0, right? Who painted the Mona Lisa? So now we've got temperature 0, minimum search score, right? And you can, I'm just doing this with the public demo, so you can also try this yourself. Oh, somehow it changed back to 0.5. Okay, let's go back to 0, 0, 0. And say who painted the Mona Lisa. Yeah, and it still wants to answer it. And that was with 0. So you can experiment more. It really likes answering that question. So Ahmed asked about changing the app service queue from B1 to higher. Interesting. So Ahmed said there's been issues with the memory. I've also heard stuff about that. So, okay. Yeah, we could do a test deploy and I can chat with the app service team to see. I don't know why we would need more CPU and RAM now than before. And so that would be worth looking into, but I will bring that up. Maybe you could file an issue about that or a discussion about it. Probably an issue about that because that'd be a code change. So go ahead and just file that in our issue tracker, and we can figure that out. I use the container apps deployment most of the time, so I don't always see the app service issues because I find container apps to be much faster deployments. And then we also got a good question from Nodirjan, which how can we store feedback scores and comments for responses Cosmos DB? Well, interestingly, we got a PR from someone who has a very similar username to you. So I don't know if you're the same person. But let me find the PR because the PR does do feedback. So this is from B Noder, who is also a big contributor. And if it's you, that's awesome. If not, but yeah, this is a PR. So check out this PR. Let me put it in the chat. And I haven't actually looked into it yet. It does also use LangFuse, so I kind of think it has like two. It's maybe it's using the LangFuse for the fuser feedback tracking. So this is only if you're using LangFuse, which is a very cool way of doing logging telemetry. I don't think this is doing it in Cosmos DB. I think I asked about whether such as Cosmos DB. So haven't followed up on that. I think that's a big feature that we need is user feedback tracking. That's that's on my list of what we should have, because if you compare us to other samples, that's actually the only X right now, at least compared to one of the main other samples that folks are using. And I think user feedback is really important and is part of the evaluation pipeline. So hopefully we can do that in the future. But yeah, generally we would stick a thumbs down button that people could click, and then we would want to track those thumbs downs, and we want to keep in mind like PII and stuff like that, and figure out what do we need to track that will help us with evaluations. But what do we need to think about in terms of privacy? So we need to think through that. But you could also check this other repo to see how they implement it, because they do have user feedback, and I believe it is tracked in Cosmos DB. Okay, all right, so we are over time. This question here was just somebody asking in a previous stream about what about chat history with access control. If you wanted to share a chat with another user, we considered a few options, but the first one would be like have cross-partition queries, and the other one wouldn't be performance. So neither of these would work well. If you did want that, we suggested having a new document type for each user that keep track of shared chats. And there's a prototype here. So anyway, if you're interested in access control for chat history, check out the slides and that gist to see what his suggestion was there. All right, so next steps, please try out the repo, post in the issue tracker or the discussions. And if you have additional questions or things you want to explore, come to the Discord office hours on Thursday. So that'll be tomorrow at 12:30 PT. You just follow this Discord invite and it should put you into the office hours. So I'll be answering any questions there, demoing things. We can play around with more prompt tweaking, try deep seeking, whatever we want to do in those office hours. It's just great to get people's questions. And then, of course, register for the upcoming sessions if you haven't done that yet. All right. Okay. So we will close for today. Thank you again for coming, for all the great questions and engagement in the chat. That's what makes it fun. And I hope to see you either in office hours tomorrow or Monday, where we're going to talk about speech input, speech output, including the real-time voice model, which is really, really fun. So hope to see you soon. Bye, everyone.
Thanks, everyone, for joining. Thanks, Pamela, for another great session. Our session is a part of the series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. Today's event code is 24575, and we will see you at the next one.